today I'm going to be talking about transformations of linear and absolute value functions. Now there's three transformations that we haven't talked about yet, we haven't seen. I'm going to quickly go over those. Now the first two is horizontal stretch and a horizontal shrink. And now if I tell you you have, let's say, a horizontal stretch of a factor of 3, we're always going to take the reciprocal of that number. So it's going to be a 1/3. And when we write this, this is going to be inside the function. So this would look something like the f of x equals the absolute value of 1/3 x. So it's going to be inside the function. Now horizontal shrink, same thing. Let's say we're talking about a factor of 1/3. This goes inside the function, so it's going to be absolute value of 3x. Now a reflection in the y-axis is when we take a negative and we put it in front of the variable inside the function. So let's say we had the f of x equals the absolute value of x plus 1. The reflection would look like the f of x equals the absolute value of negative x plus 1. So we put that reflection in front of the x value inside of the function. All right, so let's take all of our transformations that we've talked about and we're going to apply it to writing some equations, okay? So the first one says, write a function h whose graph represents the indicated transformation of the graph of f. And you may use a graphing calculator to check your answer. Okay, I'm not going to use my graphing calculator to save some time, but you can go into your graphing calculator and plug in your original function and the one that you've written to check to see if that translation is correct and if your answer is correct. So that's a good way to check your answer. Okay, so for number 1, I tell you that f of x equals x plus 2, so we're dealing with a linear function. And I tell you that the new function is a translation 2 units to the right. Well, when we go left and right on our graph, that's something where we write it on the inside of the function and we take the opposite. Meaning if it's to the right, it's negative. If it's to the left, it's positive. So our new function is going to be the h of x equals, and we're going to put it inside the function, so it's going to be an x minus 2 plus 2. Now we can simplify this because we can distribute effectively this 1 right here because we don't have any absolute value. We don't have an exponent there, so we can distribute our 1. So we can simplify this to h of x equals x minus 2 plus 2. So our new function is the h of x equals x. And like I said, if you put in x plus 2 and then you put in x, you'll see that there'll be a translation of 2 units to the right from the old to the new function. Okay. Our next one, we're still dealing with a linear function. We have the f of x equals 2x minus 9. And now we're dealing with a translation of 6 units up. When we go up and down, it's going to be on the outside of the function, and it's going to be the same sign. So that's kind of the outside, the same sign. So if up, it's plus, if it's down, it's minus. So our new function is going to be the h of x equals 2x minus 9, and since we're going 6 units up, we're just going to add a 6 at the very end, and now we can simplify. So our function is the h of x equals 2x minus 3. And that is our new translated function. Now let's look at something if I give you a graph, all right? So it says, write a function g whose graph represents the indicated transformation of the graph of f. Use a graphing calculator to check your answer. So we're looking at this, and the f of x equals the absolute value of 4x plus 5. If we look to the right to the graph, I've drawn that in black, and I've labeled it the function f. And now we're going to rewrite an equation of the transformation to g, the red one. Now if we look at it, all that's happened is that it's actually moved up 1 unit. It's moved up 1 unit. It hasn't gotten fatter, it hasn't gotten skinnier, it isn't reflected, so it's moved up by 1 unit. And if we go up by 1 unit, we add that on to the end of the function. So that's going to be the g of x equals the absolute value of 4x plus 5. and we add on the 1. So we can simplify this to be the g of x equals the absolute value of 4x plus 6. And like I said, you always can put in the new and old function and double check that you've got the right answer. So that's a really good self-check method. All right, let's go to the next slide. This time we're going to be talking about reflections. Okay, so we're writing a new function h whose graph represents the indicated transformation of the graph of f. And we can always use a graphing calculator to check our answer. So this one, we're starting with a linear function. We have the f of x equals 1/2 x minus 3, and is a reflection in the x-axis. When we have a reflection in the x-axis, we multiply by a -1, and it's going to be in front of the function. We multiply by a -1, and it's going to be in front of the function. So we're going to rewrite this as the h of x. So we have the h of x equals a negative, and make sure we have a parentheses because it's in front of the entire function, and that's going to be a 1/2 x minus 3. And now we can distribute that negative to simplify. So we now have the h of x equals a -1/2 x plus 3. And we have now our reflection in the x-axis. Our next one, we're dealing with an absolute value function. We have the f of x equals the absolute value of 2x minus 1 plus 3. And this time we're doing a reflection in the y-axis. Now when we have a reflection in the y-axis, we multiply by a -1, and it's inside the function, and we multiply in front of the x. All right, so what this is going to look like is the h of x equals absolute value of -2x minus 1 plus 3. And that's it. We just put it inside the function in front of the x, the coefficient of the x. So that's our reflection. The next one, we're going to be talking about vertical and horizontal shrink and stretches, okay? So we're going to write a function h whose graph represents the indicated transformation of the graph of f. Okay, so the first one is a linear function. We have the f of x equals 2x plus 6. And we're going to have a vertical shrink by a factor of half. When we do this, we multiply by the factor, in front of the function. Kind of the same as the reflection in the x-axis. So this is going to be the h of x equals 1/2, and then remember it's in front of the entire function, so we're going to put this in parentheses and then we can distribute. So you have the h of x equals x plus 3, and that's our newest function with that translation, okay? And then our next one is a horizontal stretch. Now remember, when we take a horizontal stretch by a factor of 4, we're going to take the reciprocal, which is 1/4, so we're going to multiply by 1/4, and it's going to be in front of the x inside the function. All right, so what this is going to look like is we now have the h of x, absolute value of 1/4 x plus 3. And now we've got our new equation, and of course we always can put this into our calculator and see if we have the correct translation and the correct equation for that translation. All right, this very last one is a graph. We're going to look at this graph, and we're going to see what happened from the f of x, the black one, to the g of x, the red one, and we're going to write a new function g. Okay, so the first one is the f of x equals 6 minus x. Well, I'm going to rewrite this into slope-intercept form, kind of make this a little bit easier. -x plus 6. So it's telling us the black graph of the line has a slope of -1. Okay, and a y-intercept of 6. Well, if you look at the red one, the y-intercept is still the same. So the g function, we're still going to have a y-intercept of 6. So that hasn't changed. We haven't moved it up, down, left, or right. So that means we've either stretched it or we shrunk it. So if we look at this, we can see that the slope is different. And if we look at 2 different points right here, it goes up 3, minus 1. So our new slope is a negative 3. So we can plug in a negative 3x, right? And now we have our new function looking at this graph. Now what I'm going to do, the very last slide, is I'm actually going to draw kind of a cheat sheet chart listing all of the different transformations and kind of how we rewrite these equations, okay? And I think this might help a little bit. So what we have is, let's think about it. The first thing that we can do is a translation up and down. And a translation left and right. All right, now when we have a translation up and down, we put it on the outside of the function. And it's the same sign as the translation. So if it's going up, it's positive. If it's going down, it's negative. Now, if it's a translation to the left and the right, we go inside the function. And it's the opposite sign. So if we're going to the left, it's positive. If we're going to the right, it's negative. The next thing we have is, let's do reflections. So we have a reflection in the x-axis and a reflection in the y-axis. Now when we have a reflection in the x-axis, we're going to multiply by a negative 1 in front of the function. If we have a reflection in the y-axis, we're going to multiply by a negative 1, and it's going to be inside the function with the coefficient of x. All right, and our very last one, let's talk about horizontal stretch and shrink. And then vertical stretch and shrink. All right, so when we have a horizontal stretch and shrink, we are going to take the reciprocal factor. So we multiply by the reciprocal factor. Okay. And where we're going to place that is going to be inside in front of the x. Okay? Now if we have a vertical stretch and shrink, we're going to multiply by the factor and it's going to be in front of the function, of the entire function. So this is kind of a cheat sheet for you guys to look at in case you're having trouble with your homework, to get all your facts in one place. So hopefully this chart helps you out.